One. Hello everyone, my name is Vikas. I'm from CSAML Section D. Uh, Today I'm to say about the how do you identify the proper wire gauge for a given circuit load. This is my topic and I want to explain this. Introduction to wire gauge selection. Proper wire gauge selection is essential for electrical safety and efficiency. It ensures the circuit can handle the current load without overheating. Understanding how to identify the correct gauge prevents electrical failures and hazards. Understanding circuit load. The circuit load refers to the total current the circuit will carry during operation. It is typically measured in amperes A. Accurate load calculation is the first step in the choosing the right wire gauge. You can see the images, get marks for all exams. Uh, you can see there is a practice PYQS and a cell phone symbols, and these are the images for the understanding circuit load. And it is useful for the water circuit load, and you can access the circuit. You can use the circuits and use the circuit breaker. And this is a understanding circuit load. And before beside the we have the image. Next, determining power requirements. Power requirements are often specified in watts W or kilowatts kW. To find the current, use the formula I is equals to power by voltage. Knowing the power helps in estimating the necessary wire capacity. And you can see the circuits. You can see the image of the power requirements. The power requirement are often specified in watts and kilowatts. The power will be calculated in the watts or kilowatts. To find the current, we use the formula of power by voltage. And knowing the power helps in estimating the necessary wire capacity. We can see the power will be stored. We can see the capacity of the power, and this is the power requirements. The calculating the current load. Uh, Divide the total voltage, total wattage, by the supply voltage to determine the current. For example, a 1500 volt appliance on a 120 volt circuit draws 12.5 amperes. This calculation guides the selection of an appropriate wire gauge. Uh, you can see wire size formula D in 0.005 into 92 power 36 minus AWG by 39. We can see the AKC mill is equals to 1000 into D square. We can see we how we can calculate the current load, and how we can we can use a formula, how we multiply, how we can divide it. We can see this type of current load, we can calculate the current load also with the wattage by by the supply voltage and the amperes. There is an example you can see. Considering voltage and a distance longer, wire runs can cause voltage drops, affecting performance. Use voltage drop calculations to adjust wire the necessary. For high distance circuits, thicker wire may be required to minimize voltage loss. Now the small heading of this top slide is concerning voltage and distance. We can take a longer wire. Runs can cause voltage drops, affecting performance. We use voltage drop calculations to adjust wire gauge if necessary. For high distance circuits, thicker wire may be required to minimize voltage loss. Wire size formula, there we can see in the image wire size formula. D is equal to 0.005 into 92 uh, 36 kAWG by 39. A K A open bracket Kc milli plus into is equals to 1000 into D square. Referencing the next slide is referencing wire gauge charts. Uh, Consult standard wire gauge charts such as AWG, American wire gauge. These charts list maximum current capacities for each gauge size. Choose a gauge with a capacity higher than the calculated load for safety margin. This slide reference the wire gauge charts, and you can see the wire gauge. There's some soft problems and units, and you can AWG, the full form is American wire gauge. These charts list maximum current capacities for gauge size. Choose a gauge with a capacity higher than the calculated load for safety margin. And we can use also the standard wire gauge will be useful for without be short circuits, protect from the short circuits. And in that way we can use the rubber without the current passes, and it will useful. uh, next Next one, considering safety codes and regulations. Follow local electrical codes such as the NEC. Uh, NEC is nothing but a National Electrical Code. Codes specify minimum wire sizes for different circuit types and loads. Compliance Compliance ensures safety and legal adherence for electrical installations. We can see here we in this slide there are safety codes and regulations. Uh, the electrical codes such as the NEC, National Electrical Code. Codes specify minimum wire sizes for different types and loads. Uh, we can use the wires as per the current, as per the current consumed. Uh, we can this is the considering safety codes and regulations. Factoring in temperature and environment. Ambient temperature affects wire current carrying capacity. In a high temperature environments, select a thicker gauge wire. Environmental factors like export to elements may require special insulation or gauze. Double check calculations and reference charts before finalizing. Ensure the chosen wire gauge exceeds the circuit's maximum load. Proper verification prevents overheating and electrical failures. And this is the verifying and finalizing the selection. Practical tips for proper wiring. Use properly rated circuit breakers matched to wire guards. Avoid overloading circuits by adhering to load calculations. Regular inspection helps maintain safe and efficient electrical systems. References: National Electric Code, AWG, wire gauge charts from recognized electrical standards, electrical wiring textbooks, and technical manuals. Thank you.